This video is for a mechanical engineering capstone project sponsored by Buck Products. The purpose was to create a shoulder pad flipping device to replace the current hand assembly process. These are examples of the completed backpacks and the sleeve and foam components to be assembled into a shoulder strap. We came up with a project statement to fulfill requirements laid out by the sponsor. Various specifications for the design included inverting the sleeve and inserting the foam, as well as not damaging any of the materials during assembly. Another major component to the assembly was to ensure the stitching lied flat across the top of the sleeve, as well as making sure the gap between the foam and the tip of the sleeve was minimal. Initial research showed common shoulder strap production processes were insewn, lamination, and insertion. Reevaluating the insertion method fit best for our design without restructuring the current process. The following videos are different examples of insertion type methods used in various industrial applications that influenced our design thinking.
This is the exploded view of the model being assembled. First, the base plate is bolted to the workbench. Next, the cylinder mounting bracket is attached to the base plate. The cylinder and pushrod assembly is placed in the cylinder mounting bracket. The mounting spacers have been placed under the opposite end of the cylinder, and both the cylinder and spacers are fastened to the base plate. Finally, the sleeve frame assembly is attached to the base plate.
Here's a SolidWorks model of our final design. On the left, you can see a pneumatic cylinder connected to a pushrod, and on the right is the frame to hold the sleeve open. The sleeve frame consists of two parallel steel rods. Here you can see how the pushrod pivots. There is a plastic stop that fits into the slot, forcing the rod to rotate in only one direction. The stop is easily removed and placed in the opposite end of the slot so that left and right straps may be made with the same pivot rod. The pneumatic cylinder pushes through the length of the sleeve, thereby inserting the foam and completely inverting the sleeve. The cylinder is controlled by a treadle foot valve that allows the user to control the speed and position of the pushrod.
From preliminary testing, we measured a maximum force of 25 pounds to invert the sleeve with the foam. Due to the geometry of the foam, the pushrod needed to rotate. 17 degrees was found to be the maximum angle required of the pushrod. With that data, we came up with a maximum loading condition of 23.9 pounds in the axial direction and 7.3 pounds in the transverse direction. Under the max 25-pound axial loading, the pushrod safety factors for yield, buckling, and fatigue were all well above 1. Also for the pushrod, the worst case combined loading due to the pivot angle was considered. The yield factor of safety was above 1 for this case as well. Similarly, the sleeve frame bracket experienced a 25-pound axial force from the attached sleeve rods, causing a bending stress. The yield factor of safety for this component was considerably over 1. The sleeve frame rods were analyzed under the maximum load combination, resulting in yield factors of safety larger than 1. The fatigue factor of safety was just under 1, so another analysis was performed under the loading condition for the smallest angle of rotation of 13 degrees. This new factor of safety was 1.23. All components surpassed the cycle threshold for infinite life. The sleeve frame rods under the maximum combined loading was under 1, but because the conservative constant 25-pound force was applied, this analysis was accepted.
Shown here is a brief outline of important deliverables that can be broken into design decisions, design analysis, and computer models throughout the design portion of the project. A complete design for the system has been created, and a list of parts and materials has been purchased and has been outlined going forward from this point. Parts will be ordered to begin manufacturing, assembly, and testing of the design.